Look at your shadow. Right now, it's sharp, clean edges. But light is a wave. Waves blur. Shadows shouldn't be sharp, but they are. Quantum physics. Light is a particle and a wave at the same time. That's impossible, but it's fact. Shadows are holes in reality, places where light refuses to exist. Shadow people, that's what they're called. For centuries, people have seen them. Dark figures, no faces. Paranormal folks say ghosts. Science says hallucinations. But what if it's a physical phenomenon? What if shadows are alive? What if they're watching us, like we watch light? 1801, Thomas Young, British physicist. He ran an experiment, the double-slit experiment. He took a plate, cut two narrow slits, sent light through. A pattern appeared on the wall, but not two strips of light, dozens of strips, alternating light and dark. Interference. That's how waves behave. Light is a wave. Young proved it, or so it seemed. 100 years passed. 1905, Albert Einstein. Photoelectric effect. Light knocks electrons out of metal, but not like a wave, like a stream of particles, photons, corpuscles of light, tiny bullets, not a wave. Contradiction? No. Quantum mechanics says light is both. Wave-particle duality. That's what it's called. When you look, particle. When you don't, wave. Observation changes reality. This isn't philosophy. This is physics, proven in laboratories thousands of times. But here's the question. If light is a wave, why are shadows sharp? Geometric optics. High school physics textbook. A shadow is where light doesn't reach. Object blocks the rays. Behind the object, darkness. Simple. Clear. Wrong. Because light isn't a ray. Light is a wave. Waves don't get blocked by objects. Waves bend around obstacles. It's called diffraction. Throw a stone in water. Waves spread in circles. Put a stick in. Waves go around it. Behind the stick, there are still waves. Blurred, but there. Light should behave the same way. Shadows should be blurred.
Fuzzy. Smooth transition. But look at your shadow. Sharp edges, clear boundary between light and dark. Why? Because light collapses from wave to particles when it meets an object. Observation again. The object observes the light. Light becomes particles. Photons fly straight, blocked by the object. Shadows become sharp. But this means objects have the property of observation. A rock observes light. A tree observes light. You observe light. Everything observes. Everything collapses waves. But who observes in darkness, where there's no light? Shadows. 2009. Quantum Theory of Shadow Particles. Scientific paper. Empty paths contain shadow particles. That's what they root. For every photon, a trillion shadow particles, invisible, unmeasurable, but affecting reality. They create sharpness of edges. They determine where light is, where shadow is. They're like anti-photons, where they're not light, where they are shadow. But shadows aren't empty. Shadows are space filled with shadow particles, parallel matter, dark matter, maybe. Shadows are the space between realities, places where our world meets another. Shadow people. Documented cases, thousands of testimonies, dark figures, corner of your eye, you see it peripherally, Someone standing there. Turn your head. Nobody. Gone. Paranormal explanation. Spirits, demons, beings from another dimension. They live in shadows, come out at night, watch people. Scientific explanation. Sleep paralysis, REM phase, body paralyzed, brain awake, body not. Hallucinations, visual, auditory, dark figures, sense of presence, fear. There's an explanation, but there's a catch. 2006, neurological study, Switzerland, Dr. Olaf Blank. He stimulated a patient's brain, left temporoparietal area, the TPJ zone. Patient said, "Someone's standing behind me." Doctor increased stimulation. Patient, "He's hugging me, preventing me from moving."
Nobody was there. Presence phenomenon. That's what it's called. It's not hallucination in the classic sense. The brain perceives a second body, its own. Error in self-perception. Brain creates a copy of the body, projects it into space. You feel someone nearby, but it's you. Your shadow. Your quantum copy. But why always dark? Why shadow, not light? Because the brain fills gaps. Visual cortex receives signal. Something's there, but no information, no light. By default, brain inserts shadow. Simplest image, absence of light. Void, darkness. Connection to shadow physics. Shadows are absence of information, places where photons don't reach, where reality isn't observed. Shadow people, the brain perceives absence. Brain sees a hole in reality, place without light, without observation, and calls it someone. Because our brain looks for faces, looks for people, even where they're not. Quantum mechanics says reality isn't solid, it's probabilistic, exists when observed, doesn't exist when there's no observer. Double-slit experiment proved this. Put a detector, particles, remove detector, waves. Reality changes from observation. Shadows are proof, places where observation failed, where light didn't collapse into particles, where reality remained a wave. Indefinite, probabilistic, non-existent. Simulation theory. Are we living in a computer program? Many scientists think yes. Elon Musk says 99% probability. Nick Bostrom, philosopher, proved it mathematically. If it's possible to create a simulation, then we're already in one, because there are more simulations than realities. Shadows are rendering glitches, processor can't keep up, low resolution zones, resource conservation. Why render what can't be seen? Shadows aren't fully rendered, only edges. Inside void, low poly space, like in old video games. Shadow people, are they NPCs? Background models, low poly, appear at edge of loading zone, disappear when camera turns. Your eyes are the camera. Level of detail system, like in video games. Close, high detail. Far, low detail. Peripheral vision, minimal. That's where shadow people appear, because system doesn't load in time. Every shadow is a reminder. Reality is imperfect.
Full of holes, full of places where physics breaks, where rendering isn't complete. We just don't notice, because we're used to it, because brain fills in, fills the gaps, creates illusion of wholeness. But shadows are always here, silently showing the cracks, showing something's wrong. Look at your shadow again. It shouldn't be this sharp, but it is. Quantum anomaly. Every day, under your feet. You walk, it walks. You stand, it stands. Or does it? Turn around fast. Did your shadow keep up? Or did it lag a split second? Shadow people. Maybe they're not strangers. Maybe it's us. Our shadows in another reality. Watching us. Like we watch light and collapse it into particles. Double-slit experiment. Observation changes outcome. You observe shadow. Shadow observes you. Which of you is real? Both. Neither. Depends on who's looking. In the quantum world, observer creates reality. You look at shadow, it becomes real. Look away, it becomes a wave. Probability. Maybe it moves. Maybe it lives its own life. When you're not looking. Physics doesn't lie. It's just stranger than we thought. Newton was wrong. Einstein was partially wrong. Only quantum mechanics came close to truth. But even it can't explain everything. Every shadow. Every dark corner. Every place without light. A reminder. Reality isn't what it seems. Light is illusion. Photons deceive us. Create appearance of solid world. Darkness is truth. Places where illusion doesn't work. Where reality shows its true face. Probabilistic. Quantum. Non-existent. Welcome to the quantum world. Where shadows break laws. Because the laws were wrong. From the start.